Recording is started. Okay, so I am picking up where we left off last night, working on building Gitea support into Digger. I did a little research this morning. Once we are done with this, setting it up into Gitea actions is going to be its own little deal. So what I am probably going to do is finish building out the changes and getting that pushed up as a branch to my fork. Then I will switch gears because I don't really want to deal with this twice because I'm dealing with a local Gitea. So I'll probably switch gears and then deploy Gitea into AWS using Terraform and probably a couple of other things from my local, um, but pushing TF state into S3 so that I can then, once everything is working, have it all be kind of self-managed in Terraform. Um, I watched the stream, a little bit of the stream here and there last night after I was done. Some of you might have noticed I pulled out a highlight that I thought was probably kind of less pertinent to this particular project and more generally pertinent and interesting to multiple things. And I noticed the stream quality, it blips and clips out and does some other weird stuff here and there. So I'm also recording this, and I'll add this to some sort of video on demand, either probably Twitch. I think I can add video on demand that's unrelated to streams to Twitch, so that'll be a little higher quality. Then I will also probably go ahead and push this out over to the YouTube. Um, since I am kind of familiar how that works. Cool. All right. So let's get back to it. I am going to clean up and refactor my quote unquote implementation. I'm totally ripping off the individual, and I mentioned his name the other day, and I'm going to try to pull this up again with annotate. I'm totally ripping off Saparov's work on the Bitbucket edition. So mad props to that individual. He, she, they, them. Um, they did a very, very nice job uh, of building this. I'm just tweaking it a little bit here and there because um, I have kind of my own way of doing things. But I will say this: if they hadn't have done such a nice job, pardon me, if they hadn't have done such a nice job, this wouldn't be so easy for me to manipulate and kind of bend to my own process. So that's pretty cool. Um, all right, let's see here. Let's start refactoring this one. So this one is the drift detection one. That calls our create job, which create job for repository. So this was the question that we had figured out last night. All right. Let's see here. So project config, if not drift detection, continue. Okay, so this is basically deciding if any of the projects has drift detection. If not drift detection, I don't like that. I don't like that at all. So if drift detection, and then we come down here, let's change that so that that is a little clearer. Okay, all right. I don't like that pattern. Like if you miss one little bang symbol, one little exclamation mark, you can totally miss the entire point of this function, which is that is not cool. All right, drift detection. Come in here. So at this point, we have the project config. Interesting. So let's go look at this because this was pulling the project config. Oh, I passed in the. I was tired last night. That's dumb. Event name, comma, event name string. Uh, and I'm also going to later on need the pull request number here. So let's do that. Uh, that's a star int. All right, that is better encapsulated. Now go to the red mark, and we can add that and that. All right, cool. So let's see. I'm trying to see if I can reuse this, and I can, because I can get project by name, but that's a little inefficient. Really, what should happen here is I create an index of projects by name, because that's how I want to interact with them, and potentially an index of projects by drift detection. But, yeah, I kind of want to do that. So, the only thing is, does Go have a dictionary type or not? I imagine it does. Um, uh, um, where's these project configs coming from? That's a more fundamental question. I kind of want to understand that real quick. Project config comes from, doesn't come from there. So, that's the repository. Digger config projects. What are these? They're just an array of projects coming in from the Digger config. Got it. I kind of feel like the very first thing I want to do is be able to look those up by things I'm going to interact with them on. What else am I doing here? Where do I interact with these? So down here, I'm going to walk through them. So I walk through the projects here. It's not inefficient the way that it was written. I'm just trying to change the paradigm. So the way he has it is he only walks through the projects once. So it's O of n every time that he does these different things. Like each of these if statements, so it's not nested. So it's always O of n. What I'd like to do is have it be, because all of them are O of n, so I'm no worse off if I move them all into an O of 1 or O1 construct. For those that don't really know, this is just all big O notation. So O of n basically means that ignoring various little side quests that are like minute one-off operations, the program or code that you're evaluating will run in a period of time that is scaled based off of the number of things that it has to go over. So like a for loop is O of n. And then applying essentially, you know, standard math constructs, you can think of O of n squared as nested for loops. So if I go through something and then through something else, that is largely going to be O of n squared, unless you know for a fact that the thing that you're like iterating over internally is way smaller, in which case it could be, you know, I forget the notation for this because it's been a long time since I've been quizzed on Big O. But there's like a, I forget what it is. Um, but it's basically like the idea is if you have a for loop that's going to go over 10 items, and then inside of that for loop you go over 2 items, then the way you would write that, let's say for loop 1 represents traversing a set called A, and for loop 2 traverses a set called B, you would say the big O notation of that is O A times B, which ends up being kind of all smashed down because these are supposed to be just like rough guidelines, but that ends up being kind of all smashed down to, you know, O of x times x, aka O of x squared. And since we always use the notation of n, meaning n things, O of n squared, um, or exponential time. Whereas, so desirable algorithms are O of 1, which means that you can just go fetch the variable that you want. Um, and things tend to be like best time or what is it? It's not best time. It's optimal time, consistent time. I can't remember now. But basically, the idea is what's the best you're gonna do, and what's kind of the not necessarily worst you're gonna do, but I forget the exact terminology. But it's kind of those two. Is it's like looking at an algorithm. So like the worst any of these is gonna be is O of n. The best any of them is gonna be because well, actually, it's not true. Some of these are going to be O of n. Some of these are going to best case O of 1. Because like the manual one, where we just care about getting the config for whatever project was specified in the envarb, if that project is the first one in the list, O of 1. If that project is second or third or fourth in the list, then, you know, best time, well, best time still O of 1 because it could have been first in the list. But that's basically the thing is like the range of that method, well, it's not even a method right now, it's a run mode. But the range of the manual run mode is O of 1 through O of n. It will never be exponential. Now, if you're looking at drift detection's best case is O of n because we're going to iterate over all of the projects. So this can never be O of 1. So the number of projects is how long this is going to take, nominally, depending on what all you're doing. So it has to run a job per project, period. If I didn't understand these things, an approach I could make as I'm sitting here dividing these up would be to be like, hey, structurally, this doesn't look as nice. This isn't as pretty. So what I want to do is, even though I'm iterating over all of the projects here, I've got the repo name because I know that from, you know, wherever I got that from out there, and I'm ultimately going to move that into here so that it's a separation of concerns. But I have the repo name. So I can just call my get, where is it? I can call my get config by project name, right? And I'm going to have the project name. That's cool because I've got it because I'm inside of that loop. People who are paying attention are going to know what's wrong with this. So I call this method, I'm like, hey, cool, go get my project name. And from the exterior, I have no indication that this is constructed as a for loop. I have no indication that they're walking over me, is they in this case, but I have no indication that they're walking over all the projects. So this is O of N. So pop quiz hotshots. On this one, if I did do um, the kind of cleaner, easier way of saying, hey, I'm going to go look this up by the project name that I've got from the project config. I'm now going over everything, O of N, throwing another thing where I'm going over everything in the middle, O of N. I have converted this into undesirable exponential time. So now this would it would increase exponentially per project that you add. I can fix that. I can have my cake and eat it too. I just have to plan a little bit. I can preload the projects into kind of an O of one lookup. And this, it doesn't, it will add another O of N earlier in the cycle of things because I'm going to iterate over all the projects. But I'm not going to iterate over all of the projects for all of the projects. It's where you get into the nested that it turns into exponentials. So I can do that. Um, it won't significantly change the time. It will mean that I'm going to iterate over the projects. It also kind of depends on what you're doing inside the loop. This one's running a job, so this is a bigger deal. This one, looking at what we're actually doing in here, we're comparing the project by name. Um, the other loop, because this is a comparison and it's a string comparison, so that's a little bit costly. The other loop, what I'm going to do is actually going to gain me a little bit of speed because I am going to load it into whatever Go's equivalent of a hash map is. And a hash map is a structure that takes a key and sets that to that value, sets that to an associative value. So what I can do is I can say, what do I look these things up by? And I tend to look them up by project name so far. I also seem to tend to look them up by whether drift detection is enabled. So like right here, in drift detection, I iterate over all of them and I check if drift detection is turned on. So that would be another thing I could index by. So what I can do is actually add uh, two hash maps and make this a little bit quicker by making it so that this thing can only iterate over things that have drift detection enabled. Because I can build the drift detection list in the beginning when I'm walking through them anyway and make it so that it's O of sub n. Uh, O of sub n or O of, I think it's O of sub n, which basically would mean I only have to go over the subset for which I actually have to do the work. So that speeds that up a little bit. Plus, it gives me a slightly cleaner interface. This one's going over all of the projects, and it's doing what? Um, it is doing what? It is running a job. This is interesting. It's running a job. It's generating a list of jobs to run, and it is checking if there is a default branch. So it's checking if there is a PR, checking if there's a PR coming in. Okay. So if there's a PR coming in that has the, if it's a PR into the default branch. Okay, that's what this is doing. So it is walking over all of the projects, which is kind of interesting. This run mode is interesting to me. So it's walking over all of the projects, only if we have a PRID and it's going into a default branch. So it's as though it doesn't know which project that PR is in, which is kind of interesting. Um, I don't really understand why that would be the case. So this is an event name is commit to default, and this is an event name. Okay, and then it's got on commit to default. Okay, so this makes sense. So basically what this is saying is we're going to have some commands for on commit to default. So this workflow is running against all the projects. So if there is a PRID set, the only thing I don't understand is how are you going to have a PR across projects? It feels like when there is a PRID, you should, like, this should look more like manual, I would think. I would think that if you had a PRID, then you would inherently know from that PRID which repo you were in, and therefore um, which project. But yeah, oh, you know what? No, I get it. So I'm betting in Digger. Let's look at what a project is. Projects. Uh, Yes. Okay. There. There. It makes perfect sense. So yeah. So a project is a directory inside of a repo. So in this case, you aren't going to have any enhancement because you're going to walk all of them anyway, which is fine. Um, you could still walk them by name and then O of one lookups, so it doesn't really change it, and it makes it kind of a little cleaner. Because then when we start passing things around, we can start passing the name around, and then in the tightest encapsulation, where we actually go to create the job and use all this config information, we can go look it up by the table. Um, Down here, this is when we have a PR, they're just doing a digger plan for each of the projects. That makes sense. And this one, well, that's if there is no PRID. So that's if you're in the repo, you're not on the default branch, you don't have a PR. So this is just going to be when there is a commit, it does a digger plan. So, but it's saying it's commit to default. This is commit to default. So when PRID equals nil, um, and the Git branch equals default. This is when the PRDID is null, which implies and the branch is not equal to default, because that would be the only way to not be satisfying. This one, show, that doesn't sound right to me. That is probably a bug I induced. Let's go and look up here, and we should see. So this one is the equivalent branch there, commit to default. Oh no, oh, it's also in the Bitbucket one. Interesting. Oh, open a bug tag for that when I get a chance. Um, I'm not going to fix it here because this is an unrelated PR. Okay, cool. So this is a commit to non-default. Um, Actually, let's go and check the granddaddy of them all, which is going to be the GitHub CI. Because that one should have manual indication, draft detect. Oh, interesting. That one doesn't do this at all. Very interesting. Very interesting. What about GitLab? Does GitLab do this? It's hard to tell because it's structured completely differently. All right. Okay, that's cool. All right. So I am going to put these into a table. I'm also going to move these to like a utils. New, go file. Uh, to get, I am going to move all of these things that I created out of here because I'm just messing up the main.go and making it look so uncool. Refactor, move, and I'm going to move them to, um, oh, crud. It wants me to check individual boxes. That sucks. Goland is still relatively immature, so some of the things that I am expecting to have work in it just don't. But that's coming from like IntelliJ. And also, it's worth noting I've been using Rust Rover a lot because I've been writing a lot of Rust because Rust is freaking cool. Um, but Rust Rover is also kind of a little jank, but it's still in like, I don't know, preview release or whatever. But any rate, I digress. Let's see, what are the names of these? I am going to make a scratch pad. That's what I'm going to do. New scratch file, text, plain text, cool, split, right. All right. These are the names of the methods that I am going, the funky funks that I am going to move over to my newly created utils. Um, None of these are Git specific, comma, but I don't really want to. Basically, this comes down to, again, being kind of a nice open source contributor. I'm making a new package. I can do in here whatever the hell I want. Yeah, I can just start adding shit willy nilly and whatnot because it's a very contained little space, and the only people that are going to look at it are me and anybody that feels like they're going to modify the Git stuff. I want to keep main, my contributions to main, tight. I don't want to be in the way of all of the people that are using Bitbucket or need to make modifications to that or whatnot, or the people who are invested in what that's doing, because that's just not cool. So refactor, move. Let's check these boxes. So in the dialog that you can't see, because when I share a window on Twitch, it does the same thing that Zoom does and everything else in the world, is none of the modals or pop-ups get shown. I don't know. I might try to fix that, but honestly, I'm using OBS for this, and OBS is super awesome in every conceivable way, except when I want to draw an area on the screen that I want to share, nightmare fuel. Like, you have to sit there and do like approximations of percentages in floating point and I think somewhat pixel offsets, and I couldn't figure it out. It's just like, this is just a massive, massive pain in the ass. Um, All right, so this, and this, I am going to move to browse. Utils, sick, refactor. Um, okay, so I'm getting an interesting list of unexported function. That's fine, I'll export them. Cool. Now they're all complaining, as should be the case. Uh, so why is that upset? I don't understand why the import changed to being unhappy. Oh, why are these called main 2? What? What? It didn't just add this, though, did it? Oh. Oh. No. Ugh, naughty. Okay, so this is in my file. Delete that import. Delete this. Uh, okay. I see what's going on. So new plan storage is in here. Mm. Are there function pointers in Go? Golang function pointer parameter. I am going to bring you all along to my documentation search. There we go. All right. What we got? What we got? Oh, that's so bright. Oh, why do people still make white websites? I do not understand. Um, okay, cool. What am I doing? Swap. Swap. AB. What is this? Passing pointers to functions. This is not a function pointer. That is a pointer being passed to a function. Ugh, I hate literal search. I going pointers on pointers as function parameters. Uh, pointer to a function. Uh, it works if you're using the signature. There is no pointer. Type hello func string. Interesting, but you still need access to it, and it's not exported. So lame. Uncool. Do not like. All right. So that means all my pretty encapsulation utilities, well, not all, but a couple, well, report and exit, I'm just going to go ahead and lift into a general utility function. Because that's like, and let's see, the log. The log is a global. Import log. Okay, so we're just importing log. I can import a log over here. Import log. Cool. Sick. All right, that solves that problem. And this problem requires that new plan storage come along for the ride, which I'm not super excited about, but it also encapsulates it in a way because what they're doing is another massive if block. Okay. And this is also going to have to be, actually, I kind of like that I'm encapsulating this over here because I have to tell you, this is going to be interesting for Gitea um, because uh, it's going to end up having to be implemented someplace, and I'm not sure where. That will be intriguing. Um, yeah. Hmm. I'm not sure what I'm going to do with that. That is going to be interesting. Plan storage. See, what are they doing? So GitHub, they're zipping it and they're throwing it in someplace in GitHub. Uh, for GCP, they're dumping it into a storage bucket. For GitLab, they're dumping it kind of nowhere. For Bitbucket and all others, they're doing nothing. So I guess Bitbucket is probably using GCP, I would hope. Um, that is interesting. Huh. Very interesting. I feel like that should be just a generalized utility because that's getting uploaded to like S3 or wherever. And that's really what should be here is it should be like GCP, S3, some other place, whatever. Because it basically looks like it's, byte file storage. Um, I know I'm going to want to put it in S3 because that's where I will want to put it for my stuff. So I'm not going to copy this. I am going to keep the generic one. And then that's going to go back to being an error. And what's going to happen there is um, I think I'm going to pass back. I'm going to change the name of this because I'm not using this in here right now. Because this can't be seen up here. Where am I using that? Get plan storage. I'm going to change that to be um, get repository owner, and then I won't need any of these. Actually, I won't need any of that because I've already got that method. Sick. Okay, so this one I'm going to de-encapsulate, and that's going to solve that whole problem. Right here. What have I done? Where was the GitHub token coming from? Oh, got it. It was just that. And the PR number was nil. Okay, cool. Um, all right, so export function, command B. Oh, so that's how you export a function in Go. You make it uppercase. That's pretty cool. That is one of those cute little hidden features of a language that you either love or it drives you completely insane. And I'm not sure how I feel about it just yet, but it does make life relatively easy. Now, what did we end up with? Report and exit. Report, error, and exit. I hate duplicate code. So ugly, but whatever. It's fine. It's fine. It's fine. It's fine. It's gonna be fine. All right. Cool. Um. So we've now cleaned up main a little bit. We're still working on cleaning this up. So I am going to I am going to defer func. Where is this used? What is a defer func? I'm learning way too much Go. Defer function Golang. Um, what is the? I fucking agree. What is the defer? Syntax defer print. They're not calling. Oh, they are. Okay. So this is a closure. Well, I don't know if they call it a closure, but it's basically just an unnamed inline function. And then they're deferring it. And then they're running it immediately by calling it with the parentheses. What the hell is this for? That's a question. Um, Multiple defer statements are allowed in the same program and will be executed in the reverse order in which they were deferred. In other words, it's a LIFO structure, so last in, first out. Okay. We invoke the greet function. The compiler will go to the defer and format println world. Oh, so inside of the context, it just does it at the end? What a stupid language feature. Ugh. Ugh. Does anybody like this? This is this is lunacy. Okay, so by putting defer in front of a function call, I can say run that at the end and essentially build a bass-ackwards LIFO structure. What a stupid idea. Why wouldn't you just take this and put it at the end? I guess it comes down to control flow. Okay, that makes sense. Actually, now I can see why you would use this, but you would only use this. So here's why I think this is a stupid feature. I don't do control flow the way, like, I don't do exiting early from methods. I hate that. It's disgusting. I like to actually appropriately map the logic. I hate return statements from the middle of whatever. Um, that said, I do like Rust, and I do like Rust's question mark ability to be able to just bail out of the function when there's an error. So I think they're using this for error handling. Yeah, os.exit. This is why. I get it. I get it. So the reason that this matters, presumably, well, actually, I don't know. I wonder if it survives an os.exit. That's an interesting question. Um, oh, you couldn't even see that because I just flipped back to the other window. So what I'm looking at is, so you got this defer. So they're registering the defer. The defer happens. well, it gets registered. The call is essentially added to a stack that basically says, hey, at the other end, do this. And it looks as though the thought process was that once um, you know, did this report, error, and exit, and you come down here and you hit this error exit code, you then are going to run the defer. Um, Recover built-in function allows program to manage behavior of a panicking go routine. So this is panicking. Okay. This is a panic handler. I see. So apparently in Go, this is just good error handling hygiene, which it's a fairly horrible pattern, in my opinion. Also, I don't know why you wouldn't register it globally. Like, why is it here and here and not here? So you aren't protected when you're on Azure, which I mean, you shouldn't be on Azure in the first place. Um, it's not here either, so you are also not protected in GitLab. You are protected in GitHub CI. So this is kind of my point. Like, why wouldn't you do that? Like, let's go look at here. Like, why isn't that defer like in main? So that if you do end up panicking in any of this mess, in any of this madness, like all the way down, like, okay, um, uh, I can't take it. I'm actually gonna have to. I'm gonna have to open a GitHub issue for that. I hate being that guy, but that just seems weird. Um, and then I'm gonna get told I'm an idiot, which is gonna be kind of fun because I'm sure there's a really good Go reason. Well, actually, I hope that there's a really good Go reason for that. But I don't know what that would be. So let's go here. And the first thing you do when you're opening an open source issue is search for search for the like search for whether or not it exists there. Um, Actually, you know what? I'm not going to open a GitHub issue because I'm in their Slack and they're super nice people. So instead, I am going to go to the contributions. Uh, all right. I'll say, so I'm just typing in Slack right now. There, I'll put you back to here so you can watch me typing. I don't have the Slack window shared, nor would I probably because there's other shit in here too. Looking at this code in the GitHub and Bitbucket CI. So I'm just writing, looking at this code, and I'm going to link the code in the GitHub CI. And actually, I'm going to flip you back to here so that I can show you how we go ahead and grab a link to the code. So we'll go to the code. First off, I'm going to jump into the main branch. Oh, I don't see a main branch. Interesting. So there's just a develop branch here. Command digger main go, and we've got this. That's the first one. Uh, and that's the. It's not there. It's not there. It is here again. All right, so I just wrote a comment. It is looking at this code in the GitHub CI, and I link to line 49, and then I link and Bitbucket CI, and I link to line 536, funcs, and noticing that we are not similarly handling panics in GitLab or Azure CI. I ask if there is. Um, a really is there some really good Golang reason not to move that defer for all panics all the way up to main to cover all CIs? Question mark. And we should see. I don't know. This will be educational. Maybe there's a really good reason that they didn't do that. I don't know what the hell that would be, but it seems to me like if you want generalized panic handling to just occur after any point when the whole thing could panic, why the hell wouldn't you want that over all of your code? Um, just seems odd, but maybe there's a really good reason. It'll be educational. So let's see here. Running mode, repository. So on our journey to clean this up, let's see what else we can do. Uh, so on the drift detection one, all right, so back to this. So now I want to we're coming up on the hour. I told myself I was only going to do this for 1 hour, and then we'll come back to it later. So let's see if we can get this built out, and this would be Golang dictionary example. Um, Golang maps. And I also want to know, so we'll go to Golang map. I want to look at, I'm not going to make the assumption. Golang map O of 1. What is the big O performance of maps in Golang? Let's find out. It's hash table, which is typically amortized O1. Okay, good. Uh, Big O complexity is a poor way to describe run times for maps. Practically speaking, the actual clock time is relevant and the complexity isn't. That, Paul Hankin, you and I can be friends. Um, that is pretty much absolutely agree. Um, the one area where it's different, and what he's calling out here is like dead on, like dead, dead on. Um, Too many people will use, well, it's O of 1 as an argument for why they can use something that's just got like total shit clock time. Um, and that's not valid. However, what is valid is using big O notation to compare, like basically apples to apples. Like when you're going and making a chunk of code more, I'm going to go ahead and talk direct. I'm probably even going to pull this out as a highlight later. But switch that off of all of these very, very bright things. Um, so basically, the note by Paul Hankin, or what was this guy's name? Yeah, Hankin, Paul Hankin, Paul Hankin, nice guy. Um, Actually, I don't even know. Could be a dick. Any rate, the the point being, when you are trying to make your code more performant, a good first pass is to look at the big O notations of things, because it will cause you to notice shit. It will cause you to notice shit that is like, okay, I nested 8 for loops here because I was, rocking the Jolt Cola and went a little nuts that night. Yes, you will see those. Looking at Big O notation, because you got to sit there and, I mean, back in the day, you'd literally like print out your source code and just like write it next to it. Right now, the way I actually go through and kind of wander my code to look at it, I just make a mental map. If it's like larger than that, I usually try to look at it in smaller pieces. Sometimes I'll throw it in a text editor and I'll screw around with it that way. Um, but in any case, the main thing I would say about that is that Big O is useful for, what's the best way to put this? Big O is it's kind of like a Bloom filter in this way. It's very good at one thing, but not very good at another. Big O is very good for seeing problems. If you are using Big O notation to justify a solution, you also need to look at the real clock time of execution of the thing, um, especially at scale. Does this matter for like, a for loop that's going to maybe have a couple thousand items in it? Probably not. Does this matter for, a hash map that's going to have like 10 or 20 items in it? Probably not. The main thing to look at, and this is the kind of wisdom that comes with experience. So I have worked at companies with like mono repos for, like their Terraform. It's actually not that uncommon for Terraform side. It's more uncommon on the code side, but even there, it's becoming less uncommon. More common. Yes, it's becoming more common on the code side to have a mono repo. Why do mono repos matter? Remember what we're talking about. I am going to go and implement a hash map that is going to allow me to walk the list of the array of projects and load them into probably 2 hash maps. Actually, realistically, a hash map and a list, because for the list case, I care about all of the ones that have the drift detection enabled. So I am going to load those into 2 hash maps. Sorry, I literally just said that correctly and then I screwed it up. One hash map in Go, and one uh, list array construct in Go for my 2 specific use cases. So I'm going to walk through however many of those projects there are. The projects in a repository is a factor of how many projects you have for your Terraform, because that's the context of what we are dealing with. Generally speaking, you will have a Terraform project per environment. So let's think about what the scale this actually is. The scale for this is going to be that the vast majority of people that are working with it, and again, this is only going to affect the people that are using Gitea, so they're self-hosted, but the vast majority of people who are working with it are going to have maybe like a staging environment, maybe like a load testing environment, potentially some sort of a shared dev environment, or two, or 10, or 12, or a couple hundred, something along those lines. But you think about like let's envision the biggest company we can think of using this thing. And I think let's see, who's the largest? Say, how many engineering employees are there at Cisco? Um, let's see, how many engineers does Cisco have? It's probably like what? We have to calculate it from the. So they got like 79,500 employees, plus however many contractors, et cetera, et cetera. Cisco's a behemoth. Um, let's see. This tells me all the ethnicity demographics. What I want is the engineering people. I think LinkedIn would actually give me that. All right. Okay, Cisco. Let's see what we got here. About insights. Insights. Let's see. 34% of total headcount, so 33,608 engineers. So let's just round up and call it 40,000. All right. That is a pretty massive scale of humans, but it is a very small scale of Terraform projects. Um, Go is a very fast language, not as fast as Rust. It's also not as fast as C or C++ or assembly language, but I digress. Go is a fairly fast language, and and actually I know there's benchmarks that kind of prove for certain cases it's faster than various of those that I just listed. But that is my personal opinion, and I am entitled to it. In any case, Go is a very fast language, iterating over a set of 40,000 projects and loading said 40,000 projects into a hash map and a list um, should be relatively straightforward. The only thing is that I'm going to have to restructure this a little bit because what I don't want to do is I don't want to adversely affect the ones of these where it walks over all of them because I walked over all of them already to look up some information. So I'm going to have to think about how that is structured, but it is on the else side of this if. So these are like the two that are kind of basically we've got like manual and drift protection, in which case we do want to do this little optimization. And then we've got essentially commits to defaults or commits to non-default branches, which is its own area. Um, and those are really kind of the four use cases. So it's basically commits to, which really those should look a little more like. So I'm only going to do it on this side. I'm going to slightly restructure the if statement. Yeah, so we'll basically build that out next. And then once that's all structured nicely, then we can go in here and do the actual work that we've been talking about, which is using the API, the Gitea API. I also this morning looked at um, Git actions and how they work. They're actually pretty slick. They basically launch a Docker. Um, I think what I'm gonna do is build out a public Git Digger uh, worker or Digger actor, I guess they call it, so that people can just grab that, and I'll put that out on Docker Hub and make it like relatively super easy to deploy into Kubernetes and whatnot. There's already one that um, I found over here. This Gitea Act Runner, which is hosted on Gitea.com. But this one, uh, super cool. It's a Git fork of Act, essentially. Um, and it basically, as near as I can tell, just lets you run some command line shit, um, which is kind of nice. But we want to actually run Digger and have Digger actually run Terraform. Um, so it's a little more specialized, but yeah, that will be pretty cool. But we aren't going to get there just yet. So the next thing is to finish kind of refactoring this and building out the rest of this new module. Um, there's not a lot left to do, honestly. There's like probably another hour's worth of work that I think I'll probably come back and take care of this afternoon. I will stream and record that. And then basically remapping some API paths and checking how the HTTP bearer tokens work, which looking into how the API works for Gitea, it's um, it looks like it's just token based, um, and you can literally just add like an authorized token. So you can also do like top TP or TOP what is that is. It's like the one-time password basic auth, but it's got like pseudoparams and other things and basic authorization and so forth and so on, and access tokens. So there's basically just multiple ways to do it. Um, I will probably just add some envarb configurations for that, and that'll be super easy. But it basically comes down to like which way are you going to do it. So you can put like token as an inquiry. So let's see here. So when I do API authorization, so I can create a query string of name, access token, and the value is whatever I told Gitea the value should be here. So that's basically just going to be like access token auth or auth type access token and then value. Literally almost all of these are going to be access token and value. There's only one that requires two, which is basic auth, which is user and whatnot. So I'm probably not going to support basic auth because I don't want to encourage people to include users and passwords when they can easily build API keys. So that one's probably a scratch. I don't know. I'll have to think about that. I don't know. I don't really necessarily want to be prescriptive, but when you have so many other options, it just seems bad. This is an authorization header. They can put whatever they want in. Um, that's basic auth, which basic HTTP auth. Um, this one's a sudo header, so sudo in a header. Uh, Probably going to handle these by basically saying header. So it's either going to be header query or basic auth if I support that. That's going to be one envarb. And then after that, it's going to be which header um, and or which query parameter. So what I will probably do is make them mutually exclusive, and then it'll just be whichever value it is, which they should, essentially put into some kind of a secret. Um, yeah, and I think like if I put that there and I hit authorize, I wonder where it stores that. So I hit log out. That's interesting. So I'm gonna have to fiddle around with this, but uh, I think these are configurable with settings on the back end too. So I'm also have to look at how the API auth works in the Git configuration. But this has gone an hour and 10 minutes, and I am trying to do these shorter and sweeter. So hopefully that wasn't too tangential for y'all. We're getting relatively close on finishing Git support for Digger. We're getting relatively close on making that a deployment. And then the fun bit, the next thing we're going to do is deploy Git into my AWS account using Terraform. Um, and after that, we will deploy probably an EKS cluster into the operations account. Um, and I'm going to have to pregame that a little bit and make sure that I'm not putting any secrets on. What I might do is record that video and then make it so I can blur things and then drop it on Twitch later. Um, that's probably the way to go about that. Just because then I don't have to do it once. I hate that shit where it's like, hey, I'm going to do this once and then I'm going to make a whole script and then I'm going to do it again. Like just raw dog it. Like, everyone learns better or learns more that way. All right, I will see y'all later. Definitely going to stream the rest of the code changes. And I also recorded this, like I said at the beginning, and I'm going to drop this on YouTube. So it'll be there too. Peace out.